Thank you very much, Susan. I appreciate that, and welcome everybody. We certainly appreciate you attending. Today's webinar was really initiated by requests from our ever-expanding audience who are looking for insights into how to best care for their boilers while I could tell they fully understood that the boiler is at the heart of any process or heating load, and its failure obviously causes the desired end result, whether it be heating or process, to terminate. It was obvious they also understood that the boiler is a dangerous piece of equipment. And though we as manufacturers go to extremes to assure as much safety as possible, when it's operated unknowingly or without regard to the safety aspects, very serious consequences can result, to say nothing about the needless loss of energy and very expensive downtime that would occur. So the focus for our discussion today will center on these three key areas: efficiency, reliability, and safety. And what we as a manufacturer with over 80 years of experience in the boiler industry, at least what we see as the best way to address these points, while providing valuable insights for accomplishing them. And we'll start the discussion today by looking at a typical process operations budget, which includes fuel and other cost areas impacted by the boiler. And as you can see on the left, the fuel spend is the major component. But the boiler will also impact other cost areas such as services, supplies, repairs, water and electricity. And if we properly understand and we operate and maintain the boiler and its ancillary support equipment, these expenses can be mitigated, or at least they can be contained. The next thing we have to appreciate, and I'll mention it again, the boiler is at the heart of any process or heating load. And when it's down unexpectedly, costs can escalate at a very rapid rate. Take, for instance, a pharmaceutical manufacturer or a food processor who has a product in a jacketed kettle or a retort, and the boiler goes down and steam is lost to the process. It then exceeds the IT or initial time for that product to move to the next operation. So it's all lost. And in many cases, this outage results in thousands of dollars of needless scrapped waste. Or we can think of an outage in a nursing home, and there's no standby boiler for supplying the required heat. So what do we go to? Salamanders to heat the building? Do we go to a rental boiler? Patient relocation? All of these are very costly. So we just have to enunciate the point that reliability of this equipment becomes so important, so imperative. The third focal point is safety, and probably the most important of all. For if it's compromised and the boiler has an occurrence, the cost associated with that can far exceed any energy savings or downtime expense. For instance, the National Board of Boiler and Pressure Vessel Inspectors conducted a fact-finding investigation to determine the major causes of boiler occurrences, including those which resulted in major damage to the building and also its inhabitants. As you can see, the survey spanned a 12-year period from 1992 to 2003. And looking at the data and considering high-pressure boilers, high-pressure steam, we find the major causes being defective low-water cutoff and poor maintenance practices. And then if we look at low-pressure steam boilers and hot water heating boilers, we find the same. And then when considering unfired pressure vessels, such as a deaerator, we can again find operator error and poor maintenance as being the precipitative cause. So when it's all put together and consolidated, you can see the culprits become very clear. Low water cutoff, operator error, and poor maintenance practices are the major causes. Now, knowing this, let's just back up just a bit and consider what's going on inside a boiler thermodynamically. Now, what you see here is a typical steam chart showing what it takes in sensible and latent energy to bring a pound of water from 32 degrees liquid to 212 degrees steam. In other words, we've gone through a phase change. Now, that's all well and good, but what I want you to see here is not the BTU input from the burner, but the expansion of this liquid when it goes from a fluid to a gas. The pound of liquid, as you can see, occupies 0.017 cubic feet. And when this same pound of water turns to steam, it occupies 26.4 cubic feet. Well, just do the math. That's an expansion of 1,600 times. And that's exactly what happened in New York City on July 18, 2007, when a steam line ruptured and all the steam and condensate released to the atmosphere, causing a massive explosion, hurling a service truck 20 feet in the air, scalding the driver over 20% of his body, while injuring several others. Everybody thought it was another terrorist attack. And you see this, and why wouldn't they? Therefore, we need to understand and appreciate the power of steam. For instance, this fighter jet weighs about 60,000 pounds and is launched from this carrier by a steam catapult. It goes from zero to 195 miles an hour in 2 seconds. And a boiler can do the same thing if it's improperly operated and maintained. And I'm talking about hot water and steam boilers together. A hot water heater in your house can do the same thing. Here you see a low water cutoff, which has not been properly blown down and maintained. We have accumulation of sludge and scale, which doesn't allow the float to reach the feed water pump on or the low water cutoff point. Now remember, the boiler is evaporating water as the load calls for steam. The pressure remains constant as the load is taking the steam, but the level is dropping. The metal is overheating. Suddenly, one of the processes shuts off, causing the pressure to spike, forcing the float into the sludge, triggering the feed pump. Bang! The overheated furnace collapses, causing all the remaining water in the boiler to expand 1,600 times, sending the boiler out of the room, similar to catapulting the jet off the carrier. This is an 8-inch header valve, which was instantly torn apart. Here is the 60,000-pound boiler, which hit this cooling tower about 150 feet from the boiler room. Lucky, because there was a playground full of kids across the street. Here's the boiler's rear door, which weighs about 1,500 pounds. It was blown through the opposite wall and lying outside. The door also took out the deaerator, and the explosion blew a large hole in the roof, as you can see. So boilers are wonderful machines which power much of our industries and provide comfort heating to a vast number of buildings. But they must be understood, they must be respected, and they must be properly maintained. Now, part of that respect lies in the appreciation of the low water cutoff as being the single most important safety device on the boiler. And yes, it requires the ultimate attention, but so does operator training. And there are any number of programs out there to assist in this effort, and they're conducted in general sessions, on-site, at the customer's facility, and online. So training is nothing that should be pushed off for mañana. It's got to be addressed today. So with all of this as a bit of background to sort of set the stage for the real meat of this program today, let's now look at what it takes to put a sound maintenance program together. You know, it starts with the organization of information, beginning with what I like to call the critical records, as you can see here. These are permanent records that you want to keep on file. Next, we have what we refer to as the dynamic records. These are things that are going to be changing on a fairly routine basis. The startup reports, the tuning reports, the repairs, inspection reports, and so on. Moving now into the boiler room itself, we have found over the years that those boiler rooms where cleanliness prevails, so does energy conservation, reliability, and safety. It just seems to go hand in hand. And it is in those operations where excellent and consistent maintenance initiatives are practiced, and they start with the daily tasks. The first is blowing the boiler down. I might want to emphasize here quickly that when we blow this boiler down, we're taking the sludge and scale from the bottom or the belly of the boiler. Okay? This is not a way to control the TDS, the total dissolved solids in the boiler. So we start by opening, let's start in the rear of the boiler, right here. What did I do? Sorry. Here you see my little pointer. Let's start in the rear of the boiler. We've got this quick opening valve which we will open. And then we have a slow opening valve here. It's going to take 5 or 6 seconds to open this slow opening valve. That's all you need to do. Open it, and once it's open full, hold it for about a second, then close it, and then close the quick opening valve. And then do the same in the front. You don't want to keep this slow opening valve open for any great length of time, because all you're doing is blowing BTUs down the drain and wasting them. That sludge and scale will evacuate the bottom of the boiler very, very quickly. Next, we want to blow down the water column, making sure we open the drain slowly so as not to damage the float. And then we just allow the differential pressure to force the contaminants to drain, and then blow down the gauge glass, as we want to make sure that it is a true indication of the water level in the boiler. Now, keeping track of the boiler's pressure and temperature, especially at the steady state, is very important, as it can tell you a lot about what is going on with the system, as well as the boiler itself, if it is unable to keep up with the load. Maybe we have a leak. Traps are blowing through, or the burner is not modulating properly, causing the pressure to decay or be reduced. Or maybe the pressure is inordinately rising, indicating the operating limit control is not opening at the appropriate time. Oh, and by the way, just a note here. I mentioned the boiler pressure decaying because of some problem with the boiler or system. But what I didn't mention was that if this pressure decay is allowed to persist, it has an impact on the boiler feed pump. Remember, the boiler feed pump was selected based on a GPM flow, but also on a given TDH at its outlet, the total dynamic head, or the pressure at the outlet. And if this decreases, if this outlet pressure decreases, the pump will run to the right of its curve, which will increase the NPSH requirement, the net positive suction head on the suction side of that pump. If that happens, the pump is going to start to cavitate. That goes on for any period of time, and you lose your pump. And there is the all-important stack temperature reading. This speaks volumes in advising you how efficiently the boiler is operating, for as indicated on the slide, a well-tuned boiler should have a stack temperature ranging from between 50 and 100 degrees above the steam or water temperature. It's also very important to note that the firing rate and pressure, when they are established, you have to make sure that you understand when you're looking at this temperature where the firing rate and the pressure are. Say that you're at full fire and you're operating at 100 pounds. So we're at full fire, 100 pounds. 100 pounds saturated is equal to 338 degrees. And your stack temperature is 410 degrees. So it's 72 degrees above the saturation, well within the line of 50 to 100 degrees. But the next week or so, you notice the temperature under the same conditions, high fire, 100 pounds operating, has risen to 450 degrees. Now that's a loss of 1% in fuel to steam efficiency, indicating either the boiler is sooting up on the fire side, or it's heavily scaled on the water side, or it has a damaged baffle, allowing flue gas to escape before going through the passes. All of which should be remedied as soon as practical, or wasteful dollars will continue to exit the stack. Turning now to a key piece of boiler support equipment, the pressurized deaerator or vented boiler feed system. Now the first thing to check is the feed water temperature, and if a deaerator, what is the corresponding pressure in the tank? Now if the DA is operating, let's say at 5 pounds, the temperature of the feed water will be about 230 degrees. If it isn't, one of the instruments is incorrect and needs to be either replaced or recalibrated, as this data piece is extremely important. Now, same with the vented receiver, which normally runs between 180 and 200 degrees. Now, if this feed water temperature drops below the normal operating point, you lose about 1% for every 10-degree drop. And if it gets really low, thermal shock to the boiler could be an issue. And the other important recording device should be part of any boiler operating system, and it's the water meter that you see in the lower left-hand corner here. This will tell you how much makeup is entering the system, which certainly may have an effect on the feed water temperature and may also impact the amount of chemical to be added to the system to avoid corrosion and scaling problems. Returning back to the boiler, we want to routinely check the gas pressure coming into the gas pressure regulator and also its downstream pressure. Now, some manufacturers will also give you a recommended manifold pressure to assure full input to the burner, and that would be what you see right here, the manifold pressure before it goes into the burner. Now, based on how many users are coming off the same device or are coming off the same service line that's also servicing the boiler, this pressure can become erratic, and it's extremely critical that we have that manifold pressure to make sure that we're making full input to the burner. Now, in the case where oil is being used for the main fuel, both supply and return pressures are recommended by the manufacturer and need to be present to assure full input. And of course, if heavy oil is employed, it needs to be a certain temperature to assure proper viscosity for good atomization. And speaking of atomization, burners employ either mechanical or pressure atomizing nozzles, or they may use air to further mix with the oil before it is atomized through that nozzle. In either case, specific pressures will be recommended by the manufacturer and must be complied with to assure a clean burn. Looking now specifically at a hot water boiler, we want to diligently monitor the supply and return temperatures, as these are the control variables which not only dictate load satisfaction based on the engineer's design, let's say it's a 20-degree delta T, but also can alert the operator that a problem is being precipitated when, in the case of, let's say, a non-condensing boiler, the return temperature gets too low. Now, this will result in flue gas condensation and serious consequences for exposed refractories and carbon steel corrosion affecting the boiler's vent stub, its pressure vessel, and possibly the stack and breaching. Next, we want to look through the boiler's sight port in the furnace in the rear and observe the flame. Now, pay close attention to this flame, especially after the boiler has been properly tuned. You know, every burner has a distinct signature, and it may be luminous and primarily blue with yellow tailings, or it may be primarily whitish yellow with a fairly tight overall shape. Then, when you see the deviations from this profile, you may want to have the combustion checked to see if anything has gone astray as far as the O2 level or the CO is concerned. Now, we already touched on checking the boiler feed system, but other routine daily observances should include the water softener, the dealkalizer if you have one, the chemical feed system, and any other equipment or operation which supports the proper running of the boiler. Now, an excellent example of this would, of course, be the maintaining the proper chemistry in the boiler water as recommended by your chemical treatment consultant. Taking samples on a regular basis and comparing them to the expert recommendations is very, very important. And we want to make sure that this is done regularly and it be documented on a routine basis. Moving now to the weekly recommendations, and because of the high safety importance that we place on the low water cutoff, we recommend an evaporation test be conducted on this device. Now, what this means is you secure or shut off the feed water supply to the boiler, and without leaving the boiler room, you watch the gauge glass and allow the water to naturally evaporate off to see if the boiler shuts off at the proper safe level. Now, if during this process the water leaves the gauge glass, shut the burner off immediately and determine the cause of the failure. This boiler should never, ever be brought back online until you know that the low water cutoff is 100% operational, and really the evaporation test is the only true way to assure this. Another thing which is often overlooked while checking the low water cutoff is the condition of the gauge glass. Now, if you see any evidence of cracking or etching or excessive cloudiness, replace the glass at your earliest convenience, because when the glass breaks, it's like a grenade going off in the boiler room, sending shards of glass everywhere and water quickly flashing to steam filling the boiler room. Pretty dangerous and pretty scary stuff, believe me. Now we again move to the fuel supply, and on a weekly basis we would suggest you check the operation of the gas valves. Now, most of these automatic valves have a window where you can observe the valve opening and it closing. You want to make sure these functions are both smooth and deliberate. And then after observing these are operating properly, open and close the manual gas cocks to assure that they are not seized and that they move freely. Remember, these manual valves are there for a reason and not just for service. They can play a key role in safety as well. If you have a single point positioning system on your burner, which is controlling the fuel-air ratio through a single motor drive connected to a shaft and various linkage rods and linkage arms and cams, this needs to be checked for free movement while assuring things are tight. We also recommend a light lubricant be applied to the wear areas of this entire system. Now, my experience shows that the best lubricant for this type of operation, for this lubrication, is the lubricant that you would use for a garage door opener, a very, very thin lubricant. We found that 10W40 tends to attract dust and dirt in these lubricated spots, encouraging eventual binding. You'll also want to pay close attention to the cams, as they have springs which can wear and break. At the same time, notice if the shape of the cam is smoothly contoured with no humps. The function of these cams is to assure as close to a linear fuel-air curve as possible as the burner modulates from low to high fire. If you find humps in the cam profile, often this signals a fuel-air fix at a certain point, and serious deviations in the ratio can occur on either side of that hump. So if this is the case, I'd highly recommend a qualified technician be called in to properly reset combustion. Many boilers out there today still have mercury-filled switches within the operating controls, and I'm talking about the operating control now, the high limit, and the modulating control. The ones you see here are mounted on a common manifold with vertical piping leading to the control itself. Now, caution here, never insulate this piping manifold, as it is intended to contain water, so the control mechanism is not exposed to steam. Steam will definitely out the control, making it non-functional and very unsafe. Observe, too, if the controls are exactly perpendicular to the manifold, so as not to bias the mercury in the switch, causing nuisance shutdowns or, again, an unsafe condition. And lastly, observe the operating and modulating controls, and while watching the pressure gauge, see if they are turning on and off at their respective set points. The flame scanner, also, or sometimes referred to as the fire eye, this is the device which is integrally tied into the burner's management system and provides the signal that the pilot and main flame are not only present, but are providing a strong electrical feedback signal. And some boiler management systems or programmers will include a numeric reading of this signal strength. We'd also recommend that the scanner be pulled out to see if the burner shuts off at the prescribed time, and that's usually between 2 and 4 seconds. And once it's pulled, also make sure the eye is clean before you reinsert it. Now, in the case you are burning fuel oil, it's important the basic checks be performed on a weekly basis. Now, this includes making sure there are no leaks in the oil metering or regulating system, and if it is leaking, You got to tighten it per the manufacturer's recommendation. Also check the delivery pressures to the nozzles in accordance with the recommendations. And if an air atomizing burner, the air atomizing pressure should be per the manufacturer's stated pressure requirement, and the integrated air compressor, if you have one, that is working properly. Sometimes plant air is used in lieu of a integrated air compressor on the boiler itself. Continuing to proceed around the boiler, it's now time to check the indicating or running lights and alarms to make sure they are functioning properly. Also pay attention to the operation of all the motors connected to the boiler, such as the blower motor, the air compressor drive motor, the oil pump motor. You know, any sign of overloading, of overheating, any bearing noise. Essentially, you're looking for noise, vibration, and just unusual conditions. At the same time, look for any leaks of fuel or water or flue gas. And after completing these tasks, I'd say it's now time to check a few safeties. For instance, the high and low gas pressure switches and the combustion air proving switch. And when doing this, make sure that you note the setting on the switch to be returned to after either raising or lowering the setting to initiate that trip. We now move to the monthly recommendations, starting with the burner. Now, the key areas of focus are shown on the slide and include the diffuser, which is the burner's mixer for turbulating the fuel and air, making a homogeneous mix, and all burners have these. It should be checked for any deformation, for any burning or cracking, and if it's found to be damaged, highly recommend you replace it. The diffuser also has to be positioned at a specific dimension per the manufacturer's or the authorized technician's recommendation. And I would suggest that you assure that this dimension is held because it's very, very important. The next thing is to look at the burner, with the burner is the pilot tube. Now, besides channeling the gas to ignite the pilot flame, it contains the electrode providing the spark for pilot ignition. The electrode needs to be really in pristine condition, located in a particular position, and it must be properly gapped between its tip and the pilot's tube's inner surface. And failure to adhere to these recommendations will certainly result in nuisance pilot failures. And lastly, it is important to check the free movement of the air damper device or devices. And at the same time, assure yourself there are no obstructions which would limit the free flow of combustion air to the burner itself. Next, on a monthly basis, we recommend checking the entire outside of the boiler for telltale signs of hot spots. Pay special attention to the gasketed flange areas and the large areas containing insulated refractory, looking for indications of overheating. Also, what you are looking at in this picture is a multiple pass dryback fire tube boiler. Now, there is a baffle in this door which separates the second and third passive tubes, and if compromised, will show discoloring of the paint at about the center of the door. You also want to make sure the site port's cooling line is connected and providing air to the insulating sleeve which protects the site port itself. And speaking of the site port, again pay close attention to the flame in the furnace and see if it looks the same as it did when it was last tuned. Remember, and as mentioned previously, each burner has a signature, and indications of trouble can be spotted in this way. However, you really can't tell what is actually going on until you conduct a flue gas analysis. So putting the burner in the manual control and using a combustion analyzer, run the burner up from low fire to high fire, checking primarily for O2 and CO at the various turn-down points. Now, if you have a 4-to-1 turn-down burner, you have 4 points to check. If you have a 10-to-1 turn-down, you've got 10 points to check. Now, if the readings are the same as when the boiler was last tuned, so note and then just move on. But if not, and the variances are extreme, for instance, you're over 400 parts per million of CO and very high excess air, Take corrective action, which normally means calling in a competent boiler burner technician to tune the burner. The 5 bullets that you see here are self-explanatory, but I did want to stress the importance of combustion air. The rule of thumb is you need 10 CFM of combustion air per boiler horsepower to support combustion. 10 CFM per boiler horsepower. Now that's 8 for oxidation of the fuel and 2 for ventilation. This means a 300 horsepower boiler requires 3,000 CFM. Now another rule of thumb to mark down is that for every 200, you take that total of 3,000 CFM and you divide it by a constant of 250, which will then estimate the square foot area required to deliver the amount of air that we are calling for, in this case 3,000 CFM. So doing the math, that's 12 square feet of open area in the boiler room. And though this area can be louvered, it should not be screened or obstructed with debris, or problems will definitely occur as far as combustion is concerned. You'll start to soot. We're now moving to the semi-annual requirements, starting with the removal and inspection of the low water cutoff bowl and its interconnecting piping. Now, we're looking for scale and sludge accumulating in these areas which was not purged during the daily blowdown. So you take appropriate action to remedy the situation by removing the plugs and rotting out the piping and cleaning the low water cutoff bowl, thereby assuring the float has completely free movement and makes the respective switches in the head assembly, which includes the pump on, the pump off, low water alarm, and the low water cutoff. And the same should be done for the auxiliary low water cutoff. Now, while inspecting the waterside condition of the low water cutoff and piping, it's also very important at this time to pay very close attention to the condition of the head assembly's wiring and switches. If any compromise is noticed, such as wire cracking or overheating, replace the entire head. Don't tamper with it. It's not worth it. The head we looked at just now, and as you saw, had mercury switches, which for environmental reasons are gradually being replaced with mechanical snap-acting switch mechanisms, and that's what you see here. And the same holds true for these. Anything looks suspicious, replace the entire head. Don't be penny-wise and dollar-foolish. If your boiler is burning heavy oil, kind of infrequent these days, the semi-annual maintenance is the time to check the oil heater, and if necessary, clean the strainer and the filter. Certainly when firing the boiler on heavy oil and the temperatures are not reached for proper atomization, the exchanger coil should be pulled and inspected and then clean it as it would be necessary. The refractory on these boilers is very important, as it not only insulates, but also plays an important role in aiding combustion and providing directional flow for the flue gases. Now here you see the burner throat and liner tile. Here's the throat and here's the liner. If it is evident while looking through the sight port in the rear that any of this refractory is severely cracked or broken, or the seal between the throat and the burner housing is compromised, you probably want to take the boiler down as soon as you possibly can to make repairs. And the same for the rear door on a dry-back fire tube boiler, this one right here. If you see extensive burning of paint or discoloration of the door on the outside, or evidence of large cracking or spalling of the refractory on the rear door by looking through the front sight port, shut the unit down and make repairs as soon as you can. And after the repairs are made, a light wash coating of refractory is recommended. The last recommendation for semi-annual inspection and maintenance is checking the pump alignment of all the base-mounted pumps in the boiler room and resetting combustion using a combustion analyzer for reading O2, excess air, CO, and emissions such as NOx, NO, NO2. Moving now to the annual procedures, annual maintenance procedures. We start with properly shutting the boiler down and opening the access doors to expose the fire side of the boiler. As shown on the screen, we want to thoroughly clean the tubes and tube sheets using a brush and a vac, or an automatic vacuuming machine which brushes and vacuums at the same time, simultaneously. Note that if you see evidence of heavy soot, that indicates very poor combustion. The burner is firing rich, not only inefficient, but it can be very unsafe. Turning your attention to the insulating materials, look for any degradation and repair, and then you have to repair these things accordingly. What we're calling specific attention to here is some manufacturers use a fiber insulating material in the areas not exposed to very high temperatures. This fiber blanket is held in place with pins and a metal screen like chicken wire to keep it from eroding from the hot gases passing over it. A rigidizer may also have been applied to the blanket to give it more rigidity and more integrity, further mitigating the combustion gas erosion. Moving now to the rear of this dryback fire tube boiler, we expose the inside of the large access door, which, as you can see, is refractory filled. Take note of the precautions on this slide. A very heavy door, is being involved here, especially on sizes 250 horsepower and above. Make sure that it's properly supported before you begin to do the work and do the inspections and so on. The door gasket also plays a very important role in assuring that all the hot gases are passing through the boiler, not into the boiler room, which is just needlessly wasting energy while causing flange distortion and possible metal fatigue. The main thing I want to call your attention to here is the importance of the inner baffle, which may be constructed using baffle tile, or it could be a homogeneous monolithic pour. Regardless of how this baffle is constructed, in this particular case, this is being applied to a 4-pass dryback fire tube, and it separates the second pass from the third pass. Compromising this seal will result in the loss of efficiency, and it could be extreme because you're bypassing these gases and they're not coming in contact with the heat transfer surface. So I'm talking about efficiency loss in the 3 to 5% range here. So if it's severely cracked or crumbling, repair or re-pour this door, or that repair or re-pour the door as soon as you possibly can. And speaking of repairing, if you notice cracks in the refractory of, let's say, 1/8 of an inch or less, don't bother with those. These are expansion or contraction cracks which will seal when the unit fires up again. But otherwise, cracks greater than this or missing chunks of refractory should be patched using the patching materials that would be recommended by the manufacturer or the authorized service representative. And now as we move to the water side of the boiler, in this picture, we have removed the manway on the top of the fire tube boiler, giving us a view of the 4th pass tubes. We're looking for heavy scaling and bridging of the tubes with scale. If this is found, you probably would have found cracked or leaking tubes when cleaning the tube sheets discussed a few slides earlier. Now, if heavy scale is found either here or at the side handhole openings on this boiler, the choice is acid cleaning and then replacing the leaking tubes, or partial or complete retubing of the scaled tubes, and then, of course, buttoning that boiler up, rolling and refastening those tubes after they've been replaced. The other thing we're looking for is any evidence of oxygen corrosion, and you can see here we found that in this boiler. There's oxygen pits, and those tubes need to be replaced. And of course, the chemical feed program either needs to be adjusted or it has to be better enforced. Now, beyond the pressure vessel of the boiler, we want to check the major safeties, and we'll begin with the gas valves. Every gas valve manufacturer has a safety test that they recommend, often involving the bubble test, utilizing ports on the valve specifically installed for this test. Now, when the valve is shut and we have upstream gas pressure on it, a tube is placed on the ports and the opposite end is put in a glass of water. The manufacturer then will advise how much leakage is acceptable, and this is expressed as the number of bubbles releasing during a specific span of time. If exceeding that limit, the valve needs to be repaired or replaced. We then move to the safety valve, making sure there is no leakage. And also that it's supported properly and then vented properly. Remember, this is the last line of defense if the high pressure limit control fails and the pressure of the boiler overpressurizes. If you see or have a piping arrangement like this, it's wrong. The common vent pipe right here, the common vent piping is too small and would allow the pressure, if these relief valves discharge at the same time, the pressure will cause inordinate stress on that vent piping, possibly causing it to break, certainly putting pressure on the safety valves, causing serious problems with those. Rather, this is what we recommend. This is the venting arrangement that should be used. As you can see, it includes a drip pan L with full-size piping coming off the discharge of the safety valve and extending into the vent pipe about 6 inches, right here. The vent pipe needs to be at least 2 pipe diameters larger than this pipe section and should not touch the drip pan, but have at least a 1.5-inch clearance from it to prevent torquing of the safety valve. Obviously, that vent pipe needs to be properly supported to allow for this. And really, it's amazing how many times we find safety valves incorrectly vented, which are posing a very serious situation if those valves were to relieve unexpectedly. We now move to the control panel of the boiler, and there may be more than one. We want to assure all the electrical connections are tight while taking the correct safety precautions in the process. Again, if we are burning oil, now is the time to check the storage tank for the level and any evidence of any contaminants in the tank. We also want to check the oil pumps for alignment and operation. Moving to the support equipment, we'll start with the vented feed water receiver if you have one. We want to drain it. We want to pull the inspection openings. We want to flush out the tank. And if it's lined, we want to make sure the lining is intact. Check the pump alignment, look for leaks, and repair if necessary, and then, of course, clean the strainers. Or you may have a deaerator. Essentially, we're doing the same thing with it, but there are more parts to inspect. For instance, the spray cone assembly. We're looking for cracking or deformation caused by alkalinity or caustic embrittlement. If this device, the spray head, is damaged or the trays in a tray type or the packing in a column type is compromised, you won't deaerate properly, and serious corrosion to the boiler will ensue. Nothing to mess with. The chemical feed systems also need to be checked and generally serviced as noted on the slide. These are dispensing the chemicals into the boiler and into the system if neutralizing and filming amines are injected into the steam line. And all of these are very, very important and critical for the overall system performance as far as reliability and efficiency is concerned. Concluding the accessory maintenance, the boiler is now ready for closing. And again, following the instructions from the manufacturer, once the boiler is buttoned up and refilled with water, it's time to fire it up and tune it up by using an analyzer which is reading out the various values as you move through the turn-down points, thereby adjusting the fuel and air linkages or actuators as you go. Now, as mentioned a couple of times before, this normally involves the expertise of a fully trained and competent combustion technician. And if you don't have one on staff, call one in, as it is well worth the additional cost to have the boiler tuned correctly. And after the boiler has been properly cleaned, closed, and tuned, I'd wait a few days and then check the following. And remember, the flue gas temperature needs to be benchmarked against the operating pressure or the temperature in the boiler and the firing rate. as these conditions will alter the result, giving false impressions. Remember, too, that for every 40 degrees of rise in stack temperature above the benchmark is a loss of 1% in efficiency. Now, early on in this presentation, I referred to the dynamic records, and the boiler room log is one of the most important ones. Now, what you see in red are what we consider the very important points to capture on a regular or daily basis. Not that the others are unimportant, but these are the must-dos as they so much impact safety, reliability, and fuel efficiency. I also mentioned at the outset the importance of operator training. And you'll recall the National Board of Inspectors highlighted operator error and poor maintenance to be a major cause of boiler incidents, some of which caused the loss of life and limb, to say nothing about the property loss and the downtime. There's really no excuse for this apathy on the part of operators, as there are any number of courses available to them which will most assuredly impact efficiency, reliability, and safety in a very dramatic and positive way. Now, we at Cleaver-Brooks have courses delivered as listed on the screen and can be detailed on our website. And there are any number of other providers out there that have excellent programs as well. It's just a matter of taking the initiative. Because, you know, knowledge is empowering, and having it goes a long way in assuring boiler efficiency, reliability, and safety. And by the way, this presentation today will be archived on our website, as Susan mentioned, for future reference. But I thought I would call your attention to an excellent tool found on our website as well, entitled the Boiler Room Guide. It's chock full of useful information, including much of what I covered today regarding routine maintenance procedures that would be conducted throughout the year. I would highly encourage you to download the PDF at your convenience off the website. And now, I'd say it's time for questions.
Thank you so much, Steve, for that very educational webinar. I hope you all found it both useful and helpful to your day-to-day activities. Would like to reiterate that, as Steve just did, that this webinar will be listed and archived on our Cleaver-Brooks website, and you can get there by cleaverbrooks.com/webinars. There will be a link to the WebEx audio, and then if you give us just a little bit, if it's not up there immediately, a PDF of the slides will be available for download. While we're waiting for additional questions to come in, we did get quite a few through our Q&A tool. I'd like to remind everybody that certificates will be available. So if you have not already indicated through the registration process that you would like a certificate of completion, upon the exit of WebEx, you will get a survey. If you would, please complete that survey for us. It gives us feedback. Plus, as Steve mentioned earlier, we decided to do this webinar because we had requests from our attendees from previous webinars, and this was something that they were interested in hearing about. So we listen to that, we try to make improvements, and we try to give you what you want, when you want it, in a timely manner as it is appropriate to your job or your functions or what you have going on. I do have them coming in. Let me go ahead and introduce Ron Churchill. Ron is on our expert panel today and will be fielding questions along with Steve Connor. Ron has been with Cleaver-Brooks for over 23 years, and he's been in all kinds of things: industrial water tube boiler field service, from product service department to research and development, conversions, and now he is a technical specialist in our aftermarket department. So we are happy to have Ron, and I want to thank you, Ron, for joining us and helping to answer these questions. Let's go ahead and get some that were earlier on. If I can scroll back through here, everyone just kind of bear with me. Here we go. Steve and or Ron, how long should the daily bottom blowdown take? Should it be a few seconds or a few minutes?
I'll take that. This is Ron Churchill. As Steve said, the bottom blowdown usually shouldn't take much longer than opening the quick opening valve and then the slow opening valve. And that's true because of the way the blowdown system inside the boiler, at the bottom of the fire tube boiler drum or shell is designed. There's about a 2.5-inch by quarter-inch piece of angle iron welded along the bottom with slots in it every so many inches, and the tappings for the bottom blowdown lines come up underneath that angle iron. It's welded in there like an A. And basically, as soon as you open that valve, all the solids that are deposited down the bottom get sucked out rather quickly. So, like Steve said, you shouldn't be leaving it open for 10 seconds and then closing. You'll be wasting an awful lot of heat, and then you're putting new makeup water in the boiler, and you got to treat for oxygen and whatnot, and you're adding more chemicals, and then you're going to be requiring more surface blowdown to take care of that. So, Steve, I don't know if you have anything.
No, I just want to say that it's not just with fire tube boilers either. You could have a vertical fire tube. You could have a water tube boiler, a commercial water tube boiler. All of these, you don't want to have that blowdown valve open for any great length of time. Just several seconds is all you need to get rid of that sludge accumulation and scale.
Yeah, like Steve said, it's all types of boilers, and typically all the steam boilers Cleaver Brooks makes, we try to employ some kind of device to spread the suction out along the bottom of the boiler where the solids are going to be expected to deposit. And I know Steve said there was a couple people who wanted some information on hot water boilers. Now, hot water boilers, you generally don't blow down. You want to keep 100% of that water in the system. So there's different chemical treatment methods in place so that you don't have to blow down with water systems or hot water systems. So we can go to the next one.
Okay, thanks, Ron. Thanks, Steve. Just want to be sure that everyone is using the Q&A tool and not the chat tool. The Q&A tool is easier for the host and the panelists to be able to see what's coming in. So if you would, direct all your questions to all panelists, and we'll try to get to each one. If we should not get to every single question, keep them coming in anyway, and we'll have Ron or Steve or somebody to get back with your specific question. All right, another question. When properly maintained, what is a typical life expectancy for a water tube, steam boiler, 100 psi, 80,000 pounds per hour steam when fired on digester gas or natural gas?
I can take that. If the boiler is properly maintained by the boiler manufacturer's recommendations, that boiler should last. First of all, we would insure it. I mean, you're looking at a life expectancy normally, as far as insurance is concerned, of in excess of 20 years. Let's say 20. But quite frankly, and I think that Ron would attest to this as well, I've been in this boiler business for a long time. I've seen boilers out there that have been well maintained that are 40, 50, 60 years old and still operating properly. They've been updated with new controls, maybe a new burner or whatever it might be. But boy, if you take care of these boilers, they'll last a real long time.
I can add something too, Steve. Regarding the digester gas?
Yes.
Like Steve said, maintenance is the thing. So the only difference would be if you're using digester gas would be the amount of hydrogen sulfides in the gas that's being burned in the boiler. And not whether it's a water tube, fire tube, I don't think in this case really matters. We would typically limit the parts per million of hydrogen sulfide in the gas for a boiler that's going to be used for low emissions to 1,000 part per million. And then for a boiler that would be a standard combustion, non-controlled, about 2,000 parts per million. And that's because it would affect the combustion for a low emissions boiler, so you need a little bit less allowed in. And the cycling of the boiler with hydrogen sulfide, the more you cycle the boiler, you're going to have condensation because the flue gas temperature is going to drop down so that it'll condense, and that'll cause the hydrogen sulfide to mix and make acid. So you'll have acid corrosion in the boiler. So there are things that can affect the life of the boiler, not only with maintenance, but on how it's operated and sized properly, so you won't cycle as much. Okay, do next.
Thanks, Ron. Next question. What is the ideal feed water pump pressure on a 12 psi boiler or a 50 psi? How much more pressure should you have?
Well, I'll take a whack at this first. It all depends upon the pressure drop between the pump discharge and the boiler itself. So the linear feet of pipe, the size, the diameter of the pipe, if you're going across a feed water valve or other valves, it's all going to take a pressure drop. Then, of course, you have to overcome the pressure in the boiler itself, so whatever the operating pressure is. it has to overcome that. So it's not really a question that I can answer specifically unless we have other, unless we know the other parameters.
Okay, and we can certainly, if there's additional question along with that question, feel free to direct that via the email that you see on your screen, and we'll make sure that we get you more details. Next question, if you were going to make a boiler maintenance plan for a client, what would be the first thing they should do?
Well, okay, the first thing you should probably do is, first of all, you get a list of all the equipment you got in your facility, all the boiler room equipment, and then try to find everything that the manufacturer might have provided you, wiring diagrams, dimension diagrams, all the manuals, and maybe get a hold of once you find that stuff, get a hold of your chemical treatment people and get them to come in and meet with you and go over all that stuff with you and put together a list similar to what Steve had shown, and then some kind of a schedule as far as what are you going to do every 15 minutes, every hour, every half day, day, week, month. And then also you come up with your chemical treatment plan. You've got to look at a lot of different things. You've got to get a water sample of your incoming water, how much water you're going to use, your fuel analysis, get all that stuff documented and taken care of so you can come up with a proper maintenance and chemical treatment plan for your water. That's
thanks,
it.
Ron. All right, let me get scroll through here. I don't know, this one might be better for you, Steve, or Ron, jump in as you feel the need. Looking at a CB level master, how does it help with the LWCO failure problem? We currently have a McDonald-Miller control and have never had a problem with it. Can you help with that one? Yeah,
you're talking about the CB level master, I think, right? First of all, let me just say that McDonald-Miller is an excellent control, and you know, we've got hundreds of them in the field in our boilers. We as a company, several years ago, we saw the problem that the National Board revealed with its studies, and that's what I just took you through, and decided to take some affirmative action on our own to address the problem. And now this level master we've made a standard on all of our high-pressure steam boilers. What it does, it combines mechanical and electronic technologies into one control, not only reflecting the position of the float at all times, enunciating when the float is near the low water cutoff point and then alarming and locking out when there is a low water condition. The control also automatically advises the operator that it needs to be blown down, and if the blowdown was in fact effective. And if it wasn't, a lockout occurs, and the control, has a high water enunciation as well, and it's got a built-in bypass which allows you to blow the auxiliary low water cutoff down without shutting the boiler off. Sometimes that's very important during some critical processes. So it's got a lot of features and advantages. But that's not to disregard the McDonald-Miller control. I mean, they're a very good company. We've got a lot of their controls on our boilers, but we have found that this level master does address the problems that were highlighted by that report by Hartford Inspection.
Okay, thanks, Steve. What is the maintenance procedure on probe-type auxiliary low water cutoff?
You said the proper maintenance procedure?
Mm-hmm.
Mm-hmm.
Okay. Okay, similar to when you're going to be ready for your annual inspection for the inspector to come in, the state inspector, you're going to have to shut the boiler down, open up the front and rear heads, and they're going to expect you to have the main low water cutout, the float cutout prepared by taking the flange off and pulling out the float and then taking all the pipe plugs out so they can see through all the piping. Now, with a probe type, there's different kinds of probe types. There's some that are mounted on top of the boiler, if it's a fire tube boiler, directly in the pressure vessel shell, sticking down in. And for that type, you'd probably have to take all the electrodes out, I guess, to have the rods attached to them, and inspect those, or maybe just replace them automatically every year. And if there's a probe type low water cutout external column style, similar like the Warwick 3EC, or on an industrial water tube, you'll have a large manufactured little column that's on the outside with 5 or 6 probes in there. Same thing. You take the probes out, and probably it'd be a good idea just to replace them because they're not that high a dollar of an item, and it's a very important item. And then have all the plugs on the piping taken out so the inspector can look in there and ensure that everything's clear and you don't need, or don't have a problem with scale buildup in that. And that'd be about, and then, excuse me, along with that, you have, they're wired into the electrical panel into relays, and you're going to want to ensure that those relays are operating properly without ever sticking, and you can do testing on your own, or talk to a Cleaver Brooks representative and have a service technician come and do a test to make sure that the water column probes are energizing, de-energizing the relays and the panels at the proper time, and all the contacts are making and breaking properly in all the relays so that everything works together properly. That's it.
All right. Thanks, Ron. And I know we're above the hour, so we're going to take a few more questions. So feel free to keep them coming. Like I said, we knew this one would be a little bit longer, and we'll try to get to as many questions as we can. If we don't, we'll certainly get back to you, but we are recording the questions as they come in. Next question, what respirator type should be used while removing boiler silicate gaskets?
What? Can you repeat that, Susan? I didn't quite get that.
I can. What respirator type should be used while removing boiler silicate gaskets?
I would imagine you wouldn't want to just use a dust mask because you're talking silica, but Cleaver Brooks isn't involved in that kind of equipment. All I can say is if I was doing it, I would want to use an actual one of those respirators that's the rubber style that's got cartridges that are properly, they're the proper type to take care of silica dust, and you'd have to talk to look on the web or something that's somebody that provides that kind of equipment to get an answer that you can, go to bed with.
Okay. When several tubes are plugged in a boiler, at what percentage of the total number of tubes should an owner begin considering replacing the entire boiler?
When they're plugged, so you're talking about a water tube boiler here?
0.
Yeah, I think that when boilers, there is a situation sometimes with fire tube boilers where if you've got a tube which is, let's say, not plugged in this particular case, but it's damaged, it's cracked, and you can't get it repaired quickly, you can plug that tube. But remember what that does is it increases the velocity of those gases going through the fire tube boiler itself, all the tubes. So it can't be done for a long time, for any length of time, but it could be a temporary repair. Now that's on a fire tube, of course, hot gases are going through the tubes and the water's on the outside. Now, if the tube is plugged in a water tube boiler, you haven't got as much heating surface in a water tube. You got plugged tubes, I'd say 0. If you've got a plugged tube, I would replace it, period.
Okay, thanks, Steve. What types of training programs does CB offer? What does Cleaver Brooks offer? Is there other things where people who are logging on now can go to get additional information on training?
Yeah, and I think I kind of mentioned it during the presentation, but I would suggest going to our website, which is cleaverbrooks.com, and then click on the training button right there on the main page. There's a training button, and then here you'll find a complete description of the courses that are offered, including the online self-paced course, along with the mechanical and electrical courses offered at the training center, which is our training center is the CB Boiler House here in Milwaukee. And there as I say, we've got mechanical and electrical courses there. And that's here in Milwaukee. And then we also have we've partnered up with Armstrong International in Three Rivers, Michigan. And there we have a 2-day program that gets into boilers, proper maintenance, operations, safety, systems, the whole 9 yards. So all of that stuff is, all those programs are highlighted on the training page on our website, cleaverbrooks.com, and also that includes tailored programs for companies. We've had companies come to us and they don't have Cleaver Brooks products, and that's okay. We're talking about steam and hot water here. We're talking about efficiency, reliability, and safety. We'll come in and we will tailor a program for that particular company, which involves pictures of their equipment. The whole curriculum is surrounded or encompasses all of their programs and all of their equipment and what they need in terms of a program to satisfy the needs of their operators and facility engineers and so on.
All right, just a couple of more questions. What is the proper O2% in combustion gas in a 300 to 500 horsepower natural gas boiler?
Okay, Cleaver Brooks has made different styles of fire tube boilers over the years, and
but Ron, may I just say that we're not just talking about Cleaver Brooks here.
Okay.
We're talking general now.
General?
Yeah.
Well, I guess that would depend if you're talking about a boiler that's uncontrolled combustion or with a low emissions. So we'll just go with uncontrolled because that's probably a bigger population out there. Typically, a low fire would be about now this is an excess air, so O2 on your analyzer, anywhere 5 to 7% around low fire, and up towards high, once you get to 30% or so, fire rate 40%, you'd probably be down around 4%, and then you may drop down to as low as 3% on up at high fire. And that's all going to depend on the type of burner and what you're firing and what the emissions are too. So it's kind of you can't make a blanket statement, but that's a general guideline, I guess.
Mm-hmm. So you're going to be a lot higher in O2
on the low end. Yes.
And as you begin to come up to mid-fire and higher, that's going to lean out.
It'll lean out, right.
Or get richer, if you will.
You have a more stable flame, so you're safer to run at a lower oxygen level.
Right. Okay. And of course, when he's talking about 3% O2, that's the same as 15% excess air. They're synonymous.
All right, just a couple more questions, and then we'll have to move on. But again, keep sending them in, and we'll record them and get back to you, especially those that are more specific. We can give you a more detailed answer to you personally. Do you have any experience with using the MAXSYS system on the fuel inlet for energy savings?
I don't.
I don't. So we would have to, I guess, if we don't have experience, we could look it up, and I'm not sure if it's similar to the fuel air ratio controller from Honeywell or if it's a FireEye system. So somebody would have to be more specific, I guess.
Okay. And here's a question that kind of relates to our topic for next month. How often should a burner be tuned? And we'll be talking about boiler tune-ups next month, so be sure that when you exit out, you can also go to our website and sign up for next month's webinar, The Art of Boiler Tuning. That will be on February the 26th at 2 p.m. Eastern, so feel free as you finish this up to go ahead and register for that. So Steve or Ron, how often should a burner be tuned?
Let me start off with this one. I would say that normally speaking, you should probably be looking at let's say twice a year, especially at the change of seasons, like let's say spring and then winter, those two minimally. So twice a year that should be tuned. The other thing is varying conditions and how much that burner is going to modulate. Now, what you're going to find on a lot of burners today is the single point positioning system that I described earlier in this presentation has been replaced by what we call parallel positioning, or actuators that then separately control the fuel and air. Those don't develop the hysteresis and slippage and so on, but if you've got and so there it wouldn't be quite as critical, but if you're modulating a lot, your load really varies, and you've got a single point positioning system with a single shaft and linkage rods and cams, you might want to be looking at more than twice a year for something like that. It might be 4 times a year where you're going to have that tuned. which might be, if you've got a single point positioning system, you may want to start to entertain the idea of changing it out to a parallel positioning system, and then of course you'd be looking at a minimum of 2 times a year.
That's exactly what I was going to say.
Good, good.
Thanks, Ron. Thanks, Steve.
I learned something.
We're going to go ahead and wrap up today's presentation. Again, I certainly appreciate the large amount of people that we had with us today. I want to give a special shout out to Kraft Foods and to Ross Management for having the largest number of attendees from a particular company. So a shout out to them, and thank you for attending. If there's something that we could present to you one-on-one, let us know. We have reps in the areas that love to do lunch and learns, and we might can schedule something for companies that have a large amount of people or a good number of people that would benefit from hearing some of these things that we've been doing lately. Keep coming. Also ask you to fill out the survey and tell us what you think, give us some feedback, and we're tweaking every time we give these things. We just appreciate the positive and the constructive feedback. And we also like to hear what we can present next go around, or we can plan in the future. So if you have something in specific that you would like to hear or learn about, let us know. And with that, thank you, Ron and Steve, for the excellent presentation and for your help with the expert panel. And we will close out and just get ready for next month's public webinar, The Art of Boiler Tuning, on February the 26th at 2 p.m. Eastern. Again, thanks for joining, everyone. The PowerPoint will be available as a PDF on the website shortly, and what we'll do is the link to the document that Steve introduced in his PowerPoint, we'll make sure that that link is included. Again, thank you all for participating, and until next time, farewell from Cleaver Brooks. Thank you.
Nicely done.